Welcome to the Contagious Code Podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome. I'm Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, I'm joined by my former CEO, Guillermo Rauch from Vercel. Guillermo is the founder and CEO of Vercel, formerly known as Zeit back when I worked there. In this episode, we go really deep. We talk about the physics of networks and how light, that is data, travels across the world. We talk about content delivery networks and how they help. We even talk about something called dark fiber cables. These are like priority lanes where your data can go faster because there's less noise. And so where there's less noise, there's more signal, data can move faster. We go into all of those details, and we also talk about how Vercel is championing a technique known as PPR. That's progressive pre-rendering of your applications to really optimize the time to first byte, meaning the time to your users seeing something meaningful as well. So your largest contentful paint or some one of those measures would become faster, and that would allow your users to actually be oriented quicker. Meaning what they would get is basically a fully static shell without data dependencies. And where the data dependencies are, it's like holds. It's almost like React Suspense, but on the server side, and you just get a static template, a stencil as it were, and then you fill in the stencil with data once it's available. The stencil would help users find their way around your application before data fills in, and then they're just ready to go quickly. We talk about that, how that works, but we also talk about, is it worth it? What proof do we have that this stuff actually matters? Why don't I just show a big spinner, for example? This episode is jam-packed with performance, networking, and edge topics, and there's so much value here. So I really hope you enjoy it as much as I did, and indeed I enjoyed it a lot. I'd like to offer this to all of you at zero cost, and this is very much separate to my day job. The way I'm able to do this is because of sponsors. If you want to sponsor this, by the way, just let me know. I'm on X at TejasKumar_. There's links, whatever, you'll find me. But I do think that would definitely help. Now, let's take a moment to thank the sponsors so that all of us have this for free, and then we'll get into the discussion. This podcast is sponsored by Code Crafters. Code Crafters teaches people how to do things like I do. My most popular talk ever is called Deconstructing React, where I taught people how React works by implementing React. We wrote a bunch of React code, but we never imported React. Instead, we did const React equals, and we just wrote it. And this really made it clear for a lot of people how it works. That's on YouTube somewhere, but the point I'm trying to make is Code Crafters teaches people this way. They'll teach you how to implement Git or Docker or something in a programming language of your choice, TypeScript, Python, Java, whatever you want. And by implementing things, you learn their mechanism. It's really cool. It's free, but if and when you decide to start paying, if you use this link and code, you get 40% off. And that is tej.as/codecrafters. There's links in the show notes as well. This episode is also sponsored by Stately. Stately is a great way to visualize the flow of logic or the flow of states. You draw these state machines and state charts, and then you fill in the transitions with code. So you can say, my application has these finite states, and this function makes you go from state A to state B. So you can draw this out and then generate code from it to really make your applications predictable. If you'd like to give that a try, go to stately.ai. This podcast actually is also is not sponsored, but is partnered with That Conference. That Conference is a conference that happens twice a year in the US, and we give away up to 5 free tickets to That Conference Wisconsin. That is, at this point in time, the most near one that is upcoming. So if you want to win that, share the podcast on social media, leave up to a 5-star review and a comment, and let me know. You'll enter a raffle to win that. Thank you to the sponsors. Thank you for sticking around. And now for my discussion with Guillermo Rauch. Guillermo Rauch, thanks for coming on the Contagious Code podcast.
Thanks for having me. Really excited to be here.
Yeah, this has been a long time coming. A number of folks have asked when we're going to hear from you, and now I hope this satisfies some. Look, I consider you one of the absolute greats in the industry. I mean, Socket.io, Next.js, the AI SDK, so much to talk about, so much detail to go into, so much nuance to capture. But for in case there's people listening who, for some reason or the other, haven't heard of any of those, I wonder if we could do a quick intro to you, to Vercel, to the things you've built, and then that will form the basis of the future discussion.
Thank you. So for a very brief intro, I started coding when I was 11, 12 years old. I quickly fell in love with open source, with the web, and ultimately with JavaScript, and with creating really cool interactive things on the front end. So that led me to the world of Node.js, to even earlier than that, a library called MooTools, where I was a core developer. I kind of became obsessed with a couple of things that kind of shaped my career. One of them was creating dev tools, making it really easy for developers to build and deploy things. Has always been an obsession of mine. The other thing was like running JavaScript everywhere, running it on the server and running it on the client and running it at the edge and running it at build time. Like I love how I sometimes liken JavaScript to English. It's the universal language that binds together lots of people. That's how you and I met, probably something JavaScript related, always in the mix. And I'm also an entrepreneur by heart. So when I first moved from Argentina to Silicon Valley, I started a startup. I sold it to Automatic, the company behind WordPress.com. They were very impressed with some of the JavaScript infrastructure projects that we built, one of them being Socket.io, which you just mentioned, which is a real-time communications framework. I'm always creating frameworks. Also created a popular ORM for MongoDB called Mongoose. But really the catalyst happened after I left WordPress when I created Next.js, which is now one of the most popular ways of building projects for the web. And I started a company called Vercel to make it really easy to deploy projects built in Next.js and other front-end modern web technologies. And Vercel has now since grown to be very large. We run lots of traffic of the web. We run very, very large websites, but also very small ones. And we help a lot of people go from 0 to 1 when they have an idea. You called out AI. A lot of these ideas are increasingly AI infused or AI powered in some fashion. So it's been very exciting to see how Next.js sort of also allows people to create AI products. And that's where we're today, sort of continuing to steward in the way that we can from our position, sort of the future of the web and create awesome open source tools for it.
Wow, that's a really great intro. I had some things I knew, some things I didn't know, so I
Oh,
appreciate
cool.
the detail there. For example, I didn't know you were involved in MooTools. We're also getting Christoph Nakazawa on the show, who was I think the creator, if
Yeah.
not one of the.
Yeah,
So
so Christoph and I were actually probably the same cohort of MooTools contributors. We're kind of a little bit later on after the project got created by this gentleman named Valerio Proietti out of Italy. And we latched onto the beauty of MooTools. Like MooTools actually in many ways, and Valerio himself, the creator, encompassed in my mind what today is defining this persona of the design engineer.
yeah,
He was extraordinarily talented and so ahead of the curve in so many different ways. But he was very good at designing really compelling user experiences. He was all about animation. He created a tool called Moo.fx. And he was
yeah.
also a very competent JavaScript engineer and API designer. So those things came together and he created this awesome project, Moo Tools, which influenced a lot of the sort of folks that ended up going to work at Facebook and created React.
Where is he today? Does he work at Vercel yet?
So, so Christoph is actually an entrepreneur himself, and
I don't mean Christoph. I mean the,
oh,
the person who created MooTools.
good question. I actually haven't kept up with him. Last I heard, he was working at Spotify, building their mobile web experience, if I remember correctly. Yeah.
Oh, there you go. Well, cool. So MooTools and then Mongoose. I had no idea you were involved with that as well. I
Oh
mean,
yeah.
look, it's so impressive just the breadth of open source. You mentioned you started in like at a really young age and then
Yeah.
fell in
I
love with
guess.
open source.
Yeah, I guess that was the advantage I had was that I became obsessed with it kind of early because I was like 16 when I was contributing to MooTools, and then when I started Socket.io, I was probably like 19 years old, and also Mongoose about the same time. Yeah, I've been all over the open source world.
Yeah, and you mentioned this is probably from the young age. Like you're also on the cap tables of various dev tool startups and investing in various of them. It seems like even getting involved in open source at a young age is sort of getting in early, right? And then you ride the curve. You rise with
Ride
the
the
advent
wave.
of
Yeah,
yeah,
I
ride
do
the wave.
like. I do love technology as in general, and I think I have a much higher tolerance for incomplete software than most people. So I was also an
Yeah.
early adopter of Bitcoin, for example, and Dogecoin. Little known fact: I helped host at the WordPress office the first Dogecoin conference in the world in San Francisco.
Wow.
So I love technology and I love riding waves, to your point. I love adopting technology early because it fills me with curiosity. And I think I can see it and I can project where things can go just because of how much I've been involved in like early things that were just a README or a
Yeah,
few lines of code and I've seen them grow. So I
yeah,
have a lot of tolerance for like pain on some level, like things that don't
yeah.
quite work well yet. But trust me, it's going to get somewhere.
Yeah, this really explains AI, Vercel, excuse me, its recent advent or innovation in the space of AI with the AI SDK. I've seen this demo of people generating a React server component, I believe, using an LLM, so a large language model, and the server component provides real time stock data. Do I have that
Yeah.
correct?
Yeah.
Um,
That's right.
yeah, that looks very similar to what you're talking about because this space is very young and evolving, and I see Vercel at the forefront, sort of playing and being inspired. So we'll get into all of that at the episode. But I want let's maybe start by talking about the thing that formed the basis of this episode, which is this blog post that Malta published today.
Oh yeah, we finally got
No,
it out.
no coincidence, I'm sure.
Yeah,
About latency numbers that every front end developer should know. And this was a take on Jeff Dean's post called "Latency Numbers Every Programmer Should Know," where
yeah,
it talks about at what duration past an interaction do you hit the L1 cache, then the L2 cache, then the disk, etc. Malta took this and sort of adapted it for the web. And I think it's a beautiful post. We'll put a link to this in the
yeah.
show notes, but it talks about, from 1 to 4 milliseconds, the Wi-Fi latency to the internet, 5G across wave latency, all the way through to LTE and then 3G and ultimately doing a round trip to the other side of the earth without fiber. Absolutely brilliant. I'm curious if we could speak to this because this came out of a post you posted on X
Yep,
about web engineers should know certain key numbers. Um,
yep.
where did that thought even come from? Were you working on something that was very slow and you went, oh, if more people knew
Good
this?
question. Good
Um,
question. I wish I'd remembered, but the funny thing is that a lot of what I do during my day, a lot of people ask me like, "What do you do as a CEO of Vercel, etc." And for a large part of what we do is still making the web faster and helping our customers get faster and more productive. So I do spend a lot of time thinking about time, no pun intended. And one of the reasons that I posted that, by the way, is I love helping people get into the industry. And I think you do as well, and giving them kind of like just broad strokes advice on what can you do to to where you want to go faster. One of the
yeah,
things that I've come across, it's super helpful, is to and I learned this from Leslie Lamport, who is the person at Microsoft Research who coined the idea of a distributed system. And he said that the thing that enabled a lot of his innovations is to think about software systems as fundamentally physical systems. So you kind of want to think from the first principles of physics and the conveyance of information at large scale and clocks in time. And that's how he ended up with a lot of the algorithms that people today use to replicate and scale databases with certain correctness boundaries. So one of the things that I do from my point of view, which is make the web faster, is think about how long things take from a
mm,
physical point of view. So one of the things that Jeff Dean included in those latency numbers that every programmer should know is, for example, the packet round trip from California to the Netherlands, and
yeah,
that's 150 milliseconds. So it's very helpful to know that as you navigate your engineering life. It's also very helpful to think about from New York or Virginia to the Netherlands, because a lot of people create cloud workloads in US East 1, which is in the East Coast of the US. So as you start creating server and client software, you want to be kind of like have a map in your head, no pun intended, of just not only the real world, but how fast things travel across the real world. So what that gives you is it gives you the nose for when something is off. I don't know if you saw that whole hack thing where like someone detected that SSH was taking longer.
yeah,
People call him the 100x engineer. The story is someone was like using OpenSSH, and they were like, "Wait a second, getting a logging refusal, getting a permission denied message was taking too long.
Hmm.
And by too long, I think it was like 400 milliseconds off. So talk about someone that intimately, I don't know if this person studied the latency numbers every programmer should
Yeah.
know, but I could have seen myself, maybe I'm not as brilliant as that person in that kind of engineering, but I see myself all the time arriving to similar conclusions. Like, wait a second, why does this particular front end take 800 milliseconds? It doesn't add up from everything
Yeah.
I know about this, like sums of numbers, right? So it's a really helpful, again, nose to develop, so you can smell like whether something is correctly engineered or not, or there's a bug, or there's something, or in the worst case scenario there is a backdoor injected by a nation state actor. So that's kind of where it came from. And specifically, the other thing that I shared that is fascinating is there's this website that helps you test how long, how much time passes when you go and click on a button between the hover event and the click event. And even if I do it, and I'm a pretty like, hyper optimized internet user, like a
Yeah.
prosumer of the internet, it takes on average every time I try it, it surprises me. It's like 300 milliseconds, 400 milliseconds. That's a lot. So
Yeah.
let's go back to like packet round trip, California to the Netherlands. What it takes a person to click the button from the moment they hovered over it is like 2-3 times what it takes a packet to go back and forth between the Netherlands and California. So imagine the amount of work that you can schedule when you hover a button. You can freaking like build the Mona
Yeah.
Lisa behind the scenes, and then by the time they click, reveal it. So this is the power of the front end, right? If we didn't have, and this is where I start shilling React, if we didn't have a rich client interaction model, and we can get into server-side rendering versus client-side rendering, all those bits. But if you don't have the power of JavaScript running on the client, then you would never be able to do optimizations like that. And maybe that goes full circle to why I fell in love with it when I was in Argentina and I was like 10 years old. And I saw, probably because the internet was also so slow and it was the early days of the web, I saw that I could do things on the browser without traveling to a server, and I lost my mind. So that's kind of
Yeah.
where like this fascination with latency all comes from.
Yeah. That's a really good job, man, going full circle. I remember similar. Like you would submit a form. The moment I saw it wasn't MooTools, it was Scriptaculous, I believe. They had similar Ajax primitives where you can edit in line and hit save, and it's not a new page. The moment I
Right.
saw this feedback loop, I was like, oh my gosh, this I need to get in on this.
Yes, same.
So those numbers, very very clear, right? What optimization like where I get hung up on this is some people make it seem as though speed and performance is like the most important thing on the web, and it may not be. It may be just one tenet of user experience, right? For example, I think you posted this on X or somebody did, but when you load Twitter.com, the domain still hasn't changed. When you load Twitter.com and you go on the notifications,
True.
you'll see like 16 spinners at once. But you'll still use the app. And we know that with streaming server-side rendering, there's a better way to do this. Vercel Next.js gives you primitives for that, especially with server components and streaming. But it doesn't seem to bother most Twitter users. What can we speak to some of the nuance there?
Yeah, it's actually really interesting because I would agree. I'm terminally in line, and I will use the word. I am addicted to X2. Like I use it a lot, and I get a lot of value from it. Like I have met so many fantastic people in the platform, and the meme. It's amazing. This website is free. Like that people toss
Yeah.
around. I can't believe this website is free. I have those moments all the time. Like I get DMs from industry leaders who want to do business with us. I've hired amazing people. So I'll say it without shame. I am addicted. And because I'm addicted, that does add a layer of bias to your analysis. You're like, well, if I'm addicted, like I don't care that it's slow, right?
Yeah.
But one of the things that was awesome, by the way, is actually I'm friends with some of the folks that work at Twitter now that I've met on Twitter. And this gentleman, Hugo, has weighed in on many of my threads, and he agrees. He actually points out that all the people are saying that like it's fine if the spinners start taking longer or whatever. They're wrong. It hurts all of their business metrics. When the website gets slower, they get less engagement. they get people dropping out, they get fewer page views, they get fewer ads, et cetera, et cetera, et cetera. And funny enough, I just visited the other day one of the largest Next.js users on the planet. Beautiful story about open source.
Who
I,
is it?
so I can't share exactly because
Oh,
they
come on.
haven't given me permission, but it's an awesome freaking website. Everybody knows it. And one of the beautiful things about open source and Next.js is an open source project, Vercel is a for-profit company, is that this company and Vercel and myself had never talked. They've been
Hmm.
just using Next.js on their own, maybe filing GitHub issues, maybe we don't even know it's coming from them. And the scale that they showed me of how they're running Next.js, it blew my mind. It was so big that it almost didn't fit in the cloud. Like that's how big it was. Just running Next.js SSR server rendering inside containers. And one of the things that they told me that actually also blew my mind, and it actually validated what the X team has shared, and some of the things that I shared in those tweets is every time they ship a client side rendered experiment, their business metrics go down. And that's how
Interesting.
they've learned the hard way because they've wanted to offload some of that compute to the client. And sometimes client side code might be easier to wrap your head around and ship and whatever. And almost always they've had to revert it and go back to server side rendering. One of the things that I've learned is, and it's funny, I don't think this gets talked about enough, is sometimes it's actually, you realize it's very, very hard to beat the iPhone in North America, the very latest iPhone doing client-side rendering in North America, where again you're like going back to the latest numbers that everybody should know, where you're like 50, 60 milliseconds at
Yeah.
worst away from US East 1. And if you're in New York, I always tell people I love landing in New York because I'm like in the cloud. Like I can feel the
Yeah.
internet gets faster because of the lower latency to US East 1. Um, yeah, so sometimes like your at home experiment might not correlate to what you experience at scale. And at scale, what you get is like less power devices and battery saving modes and older iPhones. Like my father-in-law refuses to upgrade his like iPhone 9 or things like that, you know. And so client-side rendering is more difficult to give a consistent experience to users at scale, especially the
Hmm.
further they get away. And this is where like the latency numbers become so important. The further away you get from the origin and the more complex the application becomes, the more likely you are to get all these round trips around the world to the server, and then you get back to physics, and you get back to, oh, wait a second, I'm in the Netherlands, and I'm now paying this like 300 millisecond ish trips to the API server. Now I just burnt 400 milliseconds at best. This is like the beautiful thing about those numbers is that they tell you like this is like an high performance link. Most of
Yeah.
the internet has very challenging routing topologies. I can get more into it, but like there's never a straight line in practice between your everyday user in the Netherlands and your cloud provider. And
Yeah.
a lot of the work that we do at Vercel is actually to make it as freaking optimized of a link as possible. So
About that, can we talk about this? Because as part of the latency, as you mentioned, right? There's you're in US East 1, everything feels faster. You're in the cloud. I love that expression. Um, I don't really know why US East 1 is so popular as opposed to US West. For some
I have a
reason, I always
theory.
thought, okay, I want to hear that. Actually, let's hear that theory now, and then I'll ask my question later.
Okay, so to not derail, but I just think it's a consequence of the evolution of like global trade. It's like the
Mm,
port of New York or whatever is like the busiest port in the world, and like it's where a
right.
lot of the sort of business is the nexus of business for the world. It's like Singapore in Asia, etc. So I think it just evolved naturally to be the interconnect, and it's also the perfect distance mileage wise, like Europe to US East 1, US East 1
Yeah.
to US West 2, like it's almost like the center of the planet for like the Western point of view. So
Yeah. Yeah, the nexus. That's so great. Yeah, because US West is like pretty divorced from Europe and
yes,
Asia and so on. Maybe not so much from Australia. Okay, so thank you. I think that theory is sound. First time I've heard it, and I agree. About these distances and the latency. Of course, in New York, it's going to be faster because you're in US East. I have to imagine even in San Francisco, this is not such a big deal. But I'm in Germany. There's people in Australia, and the distances do matter. Recently, Vercel did an experiment about the edge features, and found that edge in some cases was slower, and I believe there was disinvestment in
Yeah.
edge compute and possibly edge rendering, although that's a bit of a gray area in my knowledge. Could you maybe speak to that and
Yeah, for sure.
and the nuance there? Yeah, for example, the question I'm really interested in is what's the next step? Is it reverting edge functionality and rendering back to data center based rendering and
Yeah, great
functionality? And
question.
yeah,
It's a perfect segue from this latency and like global distribution map that we were just talking about, right? So you call that Frankfurt. In Frankfurt to US East 1 had, or you call it Berlin or Germany. Frankfurt is a data, I always think about it in terms of data centers. So I think like Germany, Frankfurt, it's where Vercel has a region, FRA 1. Um, so US East 1 to Frankfurt is a 100 millisecond round trip, best case. It's a lot of time. So this is where the edge rendering narrative sort of started. Wait, should we go to US East 1? Can we start? What about 10 milliseconds? That's 10 times better, right? So what if you're opening at trivago.com, for example,
mm-hmm.
and I want to buy a flight, hotel, whatever. So can I give you an experience there locally at the edge as close as possible to the visitor? So the theory was compelling, or the hypothesis, I should say, was compelling because, we know that every time we improve LCP, FCP, rendering performance, we improve the business performance of our customers.
Yeah.
The tricky thing became, and it goes back to this idea of round trips and where the data lives globally by default. We couldn't do that without making sure that the customer had their data also globally distributed. So what ended up happening is, because in practice, people put their data in maybe typically one place, realistically.
Yeah.
You worked at companies like Zeta, you've seen, like when folks create their PostgreSQL clusters or instances,
Yeah.
more often than not, they create it in one place. And if
Yes.
it's a German company, they'll create it in Frankfurt. But they'll probably serve visitors from all over Europe, right? And if you're an American company, you're likely going to create it in US East 1. In fact, I would argue even German companies probably should create a lot of their workloads in US East 1 just because if they're serving US customers, like
Yeah.
it's going to be that global average that we just talked about. So what ended up happening is, and we tested this out with two workloads, V0 and Vercel. We went all in on edge rendering, which is this idea that you run the compute at the edge of the network. And then we started succumbing to a number of things. One is the data. If it's not at the edge is actually not doing much.
Yeah.
The other one, actually paradoxically, is that you increase the frequency of cold starts. And the more pops you have, the more cold starts you're going to have. So even though the cold starts for edge runtimes are lower, now you're increasing the likelihood that, oh, I just connected from US Central or from Sydney or from Singapore or from Frankfurt. And then you get into the problem of, like, for example, a very simple case is if you have to check for authentication state with the database,
Oh
and
yeah.
then you can actually render a list of financial transactions. Those are not at the edge. So now we talked about that 100 millisecond latency between like Frankfurt and US East 1, and like, okay, now I get dinged twice. So what we ended up doing was we reverted it to SSR with streaming. Actually, it's very important to make this clarification.
Distinction.
Yeah, in one region, which is where we had the database, and that ended up being faster. It actually ended up being faster to the point where people would come to us and like internally at Vercel was like, "What do you do?" Like, so
Wow.
it was kind of fascinating that by reverting the overfitting of compute and focalizing it where the data was, and then streaming as the data and the compute are happening, ends up being the best experience. Now, that doesn't mean that we throw away the concept of a global edge network with the bathwater
Of course.
entirely. So we also added later on a feature that we called PPR, which what it allows you to do is it allows you to do some of the experience to that Frankfurt customer within the desired 10 milliseconds. So what we do is at build time, we compute, I call it almost like the stencil of the page, like think
Hmm.
Banksy, like what would the page look like if all the dynamic parts are not there?
Mm.
And some static parts can be like content, things that come from the CMS, the company name, company description, blog
So if
post,
we tie
whatever.
this to React, this would be server components. These would be components that are not interactive. They render holds where client behavior would be.
Yeah, it would be the pre-render. The
Right.
server components would be doing data fetching, and specifically the server components that do static data fetching get pre-rendered.
Got it.
And the other model to think about is the suspense boundaries that are associated with dynamic data. We
Hmm.
we pre-render the fallbacks of those. So it's really cool
Yes.
because in Frankfurt you would get like the logo of the company, the navigation, and maybe a filled circle for the user to sort of come in. Even though we haven't touched the database yet, we can like give you that like pre-render at the edge. And then, and this is also very important, the edge itself connects to the origin location, and there can be multiple origin locations, and then begins the stream of the dynamic content, which could be your user state, whether you're logged in or not. It can be your product recommendations if you're on e-commerce. It can be an example I'd like to give is the shipping estimate. If you're a returning visitor to a website, the shipping estimate depends on your user profile and where you live. And you care a lot about that because you might make a decision of buying a product or not, whether it ships fast to your house, right?
Yeah.
So that's where, like, I think over-indexing on static site generation and why it failed is it also tells that tale
Yeah.
because what merchants want is hyper personalization, and that's what people have gotten used to with Amazon.com. So that's where the failures of like let's go all in on static kind of happened. Let's go all in on dynamic is actually arguably also bad because you don't get that like fast snappiness at the edge, right? So what we did was like find this best of both worlds, and we ended with PPR at the edge, which is a static payload, and a dynamic server-side rendering stream from where the database lives.
Interesting. What is PPR? Can we expand that?
Yeah, so PPR, it's this technology I just talked about. It's called partial pre-rendering. It's what
Got
creates
it.
that stencil that I talked about, and we can
Right.
put it at the edge. But here's a critical distinction. It doesn't run any compute. It's almost
Yes.
like at the olden days of like Jekyll. It's literally
Hmm.
a static HTML that lives at the edge. Uh, and it gets a little interesting here. We concatenate a dynamic stream to that static payload. Does it make sense? So it's like the meme guy is crazy. Like
Yeah.
we
Yeah.
give you the static parts, and then we don't even wait for the client to. The client doesn't load any JavaScript.
Right.
It's the edge proxy that says, please bring me the dynamic parts now. This user is going to wait to fill those holes in the stencil. So it almost is like the concept of islands in some way. And most people, this is what's beautiful about this technology, get the benefits of PPR without doing anything.
Yeah.
So at build time, Next.js is going to do a pass, and it already does it if you turn on the flag. It's an experimental flag. Next.js will try and pre-render all your pages. And then it's going to output these PPR static assets.
So what it sounds like is it's available to everybody through one config flag that is developers and users, and
Yeah,
it also sort of acts as a linter about your suspense boundaries, if I understand
I love
correctly,
that.
right? Like meaning,
Yeah.
yeah. So if you added suspense boundaries in the right place, you get the benefits of PPR,
Yes.
and you just render almost
Brilliant.
either skeleton UI or some placeholder. And the moment the edge node serves you the static Jekyll HTML file, whatever, it also then starts streaming in personalized data from the origin, which is maybe US East or some
Correct.
some data center like that. Okay, this is great. Can we just clarify the use of compute here? It means executing code on the server. So data
Correct.
fetching, maybe authentication,
Correct.
whatever it may be.
Which is
Great.
meaningful because it costs people a lot of money. Like compute is the transmogrification of energy into,
Yeah.
like things happening. So compute costs money and compute takes time. This is
Yeah.
the dreaded cold start problem. Fascinatingly enough, PPR is also a partial, I should say, no pun intended, solution to the cold start problem because we can reason about
Yeah.
that static pre-render at the edge. We can think of it as a predictable artifact. It doesn't matter how big it is, how small it is. It takes us constant time to flush it to the client. We don't have to spin up a sandbox, a security boundary, a micro VM, a
Yeah.
firecracker instance. And meanwhile, we request the compute from origin. So I'm very jazzed about it. It's a pretty neat idea.
Yeah. No, this is, I would say this is extremely on brand with Vercel and even Zeit back in the day, because I remember many, many, many years ago, Timer, he's probably still
Yes.
at Vercel.
Yeah, he
He's
is.
very loyal. Timer opened a pull request on my like Next.js 8, Next.js 9 website, adding support for ISR. And ISR is, if I understand correctly, basically PPR,
Yes.
but PPR has holes that become interactive
Correct.
later, right?
Brilliant. I
Yeah, so
also
it's
love your
it's it's
linter metaphor. It's brilliant. Like, so maybe for the audience, if your suspense boundaries are not granular, you just
yeah,
build an stencil which is the size of the frame. It's like it's a boring
yeah,
stencil.
yeah,
If you put them where the dynamic parts are, now the PPR, I sometimes internally I call it, the largest contentful paint. Google
exactly.
invented the word contentful. Your PPR pre-render becomes more contentful, and that feels better because I'm in
Yeah.
Frankfurt. I open it. I was like, "Ooh, I have a lot of content. My brain is
Yeah.
processing."
And everything's your brain and your eyes can orient you on the page already,
Yes.
and then as soon as that data fills in, you're ready. I love that. I love that you and I and all the listeners care a lot about not just performance for the sake of performance, but really user experience.
Yeah,
Fundamentally, that's what this
totally.
is, right?
Quality
And
and good
and
experience.
yeah, and Next.js facilitates this user experience with its world-class developer experience. So I think we're on a good way here. You mentioned the edge node that serves the PPR stencil also then immediately, as soon as it receives a request, so even before it flushes, will send a request to the origin server in a data center and ask for like personalized information. Is there not like distance based latency there? Meaning if I,
Yes, 100%.
get this stencil from the Frankfurt edge, but it needs to go to US East, that will probably also be slow, no?
Yes, 100%. But this is where the question about where your data resides becomes so prominent. Because again, idealistically, the data would be everywhere in the world. I mean,
Yeah.
let's even face it. Like, why not even push all the data of the entire internet into my device? Then the compute doesn't even leave the device, right? Like, I just go to like Walmart.com and it doesn't even
Yeah.
go to the internet. It's all being synchronized in real time. So this caricature actually does illustrate the point of synchronizing data worldwide is extremely expensive. It's expensive to replicate and it's expensive from an engineering standpoint. Now I'm going to bring it back full circle like Leslie Lamport. Reasoning about consistency in distributed systems is like an obnoxiously difficult subject. And this is
Yeah.
why most people, you'll hear them punting the problem of globally distributed systems. You'll hear a lot, maybe I'll saturate the limits of my MySQL database or my SQLite instance over here. And let me reason about everything with ACID semantics. So I don't have to worry about staleness and caches and try to push out the need for replicating and caching. Those are things that cost money in the form of engineering time. So as engineers, and this may be another career recommendation of the form of like know your latency numbers is think like an economist and think like an investor. You are the economist. In fact, people that work with cloud are now interacting with CFOs in the finance office of companies more than ever. Like it used to be that
Mm.
engineers were like, okay, here's your budget, do something with it. It's kind of inverted now. It's like Timer teaches our CFO about cloud economics and like how these things work and what the trade-offs are. And one huge trade-off is where the data lives from a cost perspective and from an engineering upkeep perspective and a code-based complexity perspective. And the other one is, we already talked, there's three things. One is gravity, the other one is cost, and the other one is residence. So gravity we touched on is if you have many round trips to the database, you're paying that cost, US East 1 to Frankfurt, 100 milliseconds, 100 milliseconds, 100 milliseconds. So you need to
Yeah.
concentrate your rendering compute next to the data. Cost is very important. If anyone has ever worked with like Dynamo Global Tables or Cosmos DB or systems like that, you'll know, oh my God, it's expensive. It's expensive,
Yeah.
by the way, even from just a data transfer agreement point of view. Like data transfer in South Africa is very expensive, in Sydney is very expensive, in Japan is very expensive. So replicating everywhere is out of the question. But also the third point that is really relevant is the the EU, maybe the UN too, and regulators are increasingly more stringent about where data should live. And
Yeah.
regulations like SOC2 and other like enterprise level like compliance requirements need certain basic oversight and controls around your data. So your data might end up living in a handful of regions, but never all of the edges of the network. So maybe you end up with like, I have a database replica or shard in Frankfurt. I have one in US East 1. And maybe if I have a lot of business in Asia, I have one in Singapore. But that's kind
Yeah.
of the conversation as opposed to like, let's run the compute everywhere and let's have the data everywhere.
Yeah. So there are costs. It sounds like that cost is sort of negligible. Again, going back to the example of I'm talking to Frankfurt, but Frankfurt needs to get data from US East 1. There's what I'm hearing is there's no way around it at this point.
Yes.
For those reasons you mentioned.
For most companies, I would say there's no way around it. And by the way, because it's only one trip that you're paying and this is the beauty of modern networks like Vercel's fast data transfer and the AWS Global Accelerator and other products like that, is that when we capture your request at the Frankfurt edge, we use what's called dark fiber. That is also kind of on brand. So we have a very high performance interconnect link that is dedicated and private between our Frankfurt data center and US East 1. So we're talking speed of light plus friction of the fiber plus, maybe a handful of switches, as opposed to
Right.
the typical, which is lower cost but slower, what's called the hot potato routing, which goes
Yeah.
over like lots of internet links. So
Yeah.
because we only make one trip to US East 1 and then we stream from US East 1, it's actually kind of hard to beat it. Like and this is why when we reverted V0 to this system, we actually became faster, even though we weren't at the edge. It's actually pretty fascinating.
About this dark fiber cable, do I understand it correctly that it's just a glass cable with very low traffic, such low traffic across it that it looks dark because it's not used so much. So it's like a priority lane almost.
It's a priority lane. That's the best metaphor.
Great. I didn't know that this is probably just an enterprise feature. I'm guessing
No,
because it's
at
very
Vercel,
expensive.
interestingly enough, everybody gets it. So our
What?
network only works with what we call fast data transfer.
Does Vercel have
customers.
physical? Even hobby customers? He says even the free tier ones. That's wild. Does Vercel have like physical data centers in places, or is it just an abstraction on other people's data centers? And feel free to not answer this, but
No,
I speak
it's totally
to
fine. No, we actually have a blog post about this. If you want to read it, we share the entire sort of architecture on top of the cloud. Currently, our network sits on top of AWS, and as you could imagine, even just like building a network of this caliber. And by the way, another thing that's interesting about partnering with the mega scalers like AWS and Azure, et cetera, is just the amount of compute that we can provision in these mega data centers like US East 1. So you kind of touched on like Vercel's become really popular for like AI products and launches. Sometimes, and when you're at Vercel, you kind of saw glimpses of this. Customers will come to Vercel and launch, and a customer, for example, of ours, Pika AI, had 800 signups in 48 hours for their
Oh my
AI
goodness.
video product. The amount of compute that we need to be able to summon unpredictably, because these customers are not saying, I have a launch, it's programmed for this day, let's
Yeah.
do a bunch of load testing. No, they're saying like, Vercel, just scale. Like
Yeah.
that's what I hired you for. So we have to be able to summon ungodly amounts of compute. And that's why we prefer to put our sort of functions and server-side rendering in these mega regions. Right, currently it's 20. That's what the Vercel network is. So when you hear edge, we're talking about those 20 edges that are on average like 10, 30, 50 milliseconds away from most of your visitors. But they have this ability to, again, provision massive amounts of capacity.
Okay, so it's is it then a software system
It's a
that
software system on
is
top of the cloud. So specifically in this system is AWS.
right, but you could also then work with Cloudflare or other providers and merge in other pops as well.
Yes.
Sounds like.
For example, Google and Azure have a lot of these pieces as well. So
Hmm.
because Next.js and many of the frameworks we support are kind of agnostic to the infrastructure, you could imagine a
Yeah.
future where you get the optimal possible cloud footprint without doing anything, just because you adopted some of the frameworks that we wrote integrations for, and we're able to integrate deeply and put workloads into any cloud of your liking.
This whole software system, I'm assuming, is not open source. I mean, that's the whole secret sauce of the company.
Yeah,
So
and I have
yeah.
two takes on that. Like, it's not open source primarily because it's what runs the entirety of Vercel, but
Yeah.
also I don't think that people. This is what I've always shared with the team is this globally distributed system is the things that I mentioned earlier that people don't want to worry about. They want to offload that to us. Like the
Yeah.
global synchronization problems, like the way, for example, our metadata, global metadata replication system works, or our global purging system works, so that when you make a content change, you mentioned ISR, you can embed all of the ISR sort of, or you get all of the ISR benefits in the PPR pre-render. But let's say that you change something in the CMS and you want to refresh all the static copies of your pages worldwide in our network. That in Vercel happens within 300 milliseconds. So
Wow.
creating the global replication system, and we could open source it. I actually much rather open source sort of how we built it. So it's much more useful for people that want to build a system like this, rather than burdening people with like, oh, hey, here is a 2,000 piece IKEA spaceship that you have to assemble in order to maybe run it. And then you need hundreds of
Yeah.
people to operate it.
Yeah. That's no, I think that's a perfectly reasonable take. When you mentioned the edge and you mentioned cold starts, I heard a few listeners gasp. This is not live, but I've developed a feeling for the because the whole selling point of edge is yes, low latency, but also low cold start with the workers runtime, for example, right?
Yeah.
Do those cold starts still really significantly impact performance in a strong way, or is it more just the distance
So as I
that
mentioned,
affects performance?
the thing we found that is fascinating is that there's no free lunch to cold starts. As we started
Interesting.
maturing our application and it got bigger and bigger and bigger, like we're talking like hundreds of kilobytes, and I believe that Malte in one of the latest numbers included the time to parse HTML,
Yes.
JS, CSS. So time to parse 1 megabyte of JS, 150 milliseconds. So just think about that. Like when you think about your cold start, there's something to the infrastructure, but actually what's worse is what you add to the
Hmm.
cold start. And by you, I mean not you specifically, but people.
Probably
So
also me specifically.
same.
Yeah.
But so I'll give you like a quick summary. So there's no free lunch. And actually, I would argue that all of this compute spinning up globally, up and down, with a maturing application with more and more JS, actually ends up being counterproductive to the cold start elimination dream. I mentioned that PPR amortizes. So because we gave you that thing, it's fascinating. Like in order to actually render a lot of pages, you need to download the critical blocking CSS and start
Yeah.
parsing the fonts and loading up the font atlas into your GPU. So while this is happening, in the event that you have a cold start, we already kind of eliminated it, which is fascinating. And by the way, if you look at our like network statistics, I think it's like 0.05% of function requests are actually cold. The other thing that we're doing is by concentrating the compute on one region or a few, we actually vastly increase the probability that you don't hit a cold start. And last but not least, and this is a sort of a pre-announcement of Vercel ship, we've done some pretty incredible work to vastly reduce the cold start profile of Node.js functions, and there's way more to come. And I don't want to like spoil the announcement, but we have made a significant breakthrough that actually helps not only in the infrastructure side, but even as your code size increases, we're able to eliminate a lot of that cold boot. So we're pretty jazzed about it. So there's a bunch of announcements coming for this.
Oh my goodness. Okay, so Vercel ship is sometime in May, right?
Yes,
May
May
6th.
23.
May 20, this episode will be live before that.
Oh, cool.
Anything at all we can speak to the implementation or for
Yeah,
engineers
yeah. I'll
about
give you
that.
some specials for your listeners. Yeah, I kind of mentioned the real battle is JS. Like, sometimes I call it like Alex Russell was right. Like JS does take time. Yeah, if he's listening, like JS does take time to load. It's not free.
Yeah.
So what we're doing is a handful. So a lot of this is already landed, which is cool. But we're going to talk more about it. We're making the Next.js runtime itself tiny, like as tiny as humanly possible, so that you don't get attacks from Next itself. We are doing a lot more with Rust. So moving things like this is the difference between Rust and JS, by the way. Like JS takes time. Rust, like Rust is as close as you can get to like saying that something is like blazing fast by design.
Yeah.
So we moved it to,
Mainly because there's no memory management, right? That's the big selling point.
there's a bunch of things. There's like no, because there's no JIT. V8 is this amazing marvel of engineering, which is a very complicated machinery, which is it does a lot of things in order to get fast once it gets warm. But before it's warm, it's almost like V8 itself is a cold start machine. And they've been adding all these tiers of compilation to try to make it less of a problem. But the trade-off that you get just fundamentally by using V8 is that it's going to get really fast, and that's why it was invented, but it takes time to get there. And this is true for like most JIT systems, whereas Rust is not a JIT. And a lot of the memory mapping that you mentioned and allocations, and a lot of that can be statically optimized. And the binary initialization time tends to be much faster than the code that becomes a guest of the V8 binary. So we are moving a lot more stuff to Rust. And then last but not least, we're doing this optimization to your code at deployment time. So you don't have to change anything about your code to drastically reduce how long it takes to initialize it. So we're kind of attacking the problem from like all three vectors.
Right.
And yeah, it basically makes it in with PPR on top. It makes it such that most users of our platform are never going to have to even think about it.
Okay, wow. I'm excited for this announcement, and I'm more excited about the whatever technical content comes out of this in the way of blog posts or papers or whatever. I will definitely read that and share. Excellent. You mentioned, okay, so this seems to be like the gold standard now. PPR, served from the edge node requests sort of personalized data. This is working well for V0. It's working well for Vercel. This is sort of the blessed path. Do I understand that correctly?
100%.
For now. Great. What if we didn't have regulation around where data should live? So, for example, in the European Union, things have to live in Germany. Assuming we don't have that, we don't have to account for that. Would it be a viable approach to leverage tools like Upstash or Terzo that have edge replication of data as well? Of course, provided data is not forced to live in one location. Yeah. Then the data is also close to the edge, and latency gets even better. Could we speak to some nuance
100%.
there?
I think those systems are awesome. By the way, I use Upstash all the time. We use Upstash as Vercel KV all the time, and we do offer replication. But again, you end up replicating to a handful of high-performance cloud compute regions, maybe 2 or 3. the idea that you would replicate it like hundreds or even more than three. By the way, something that Malte, I've heard this from both Malte and Tomo. When they came to Vercel, moment of vulnerability, it was kind of a head scratching moment how obsessed we were with the edge because they worked at Google and Facebook, and neither of those does edge replication.
Mm.
And I call those companies like they have the money printers.
Yeah.
As you can see with Zuck open sourcing like $10 billion models, whatever, like
Yeah.
that is all based on. I don't know if you saw the photo of like old Zuck, new Zuck.
Yeah. Yeah.
Zuck is
Yeah.
stealing your data and Zuck is stealing your date because he's hot Zuck. Um,
Yeah.
so
Hot open source
so
Zuck.
even Zuck that like casually orders 750,000 H100s does not
Yeah.
replicate Facebook's and Instagram's and whatever's data to more than a handful of regions. And I don't want to speak to the exact amount, but we're talking like single digit and
Yeah.
maybe five. So, and again, as companies grow, you have to account for like volume of data transfer replication,
Yeah.
latency. Latency is a huge deal. And I remember actually Facebook wrote an amazing blog post about how I think they had found some kind of like TCP kernel buffer bug where because I think it was like cross coast replication, uh, it was getting like the replication log was getting clogged up. So again, it's super useful of a technique. It's super useful in optimization. You want to deploy it very consciously. Like again, think like an economist. What am I getting in return?
Yeah.
Now, there's something really cool that others are exploring in the space. I think Torsus is exploring this, and there's a company called Nile that is exploring this, which is sharding more easily, so that I can say all my European customers go to the Frankfurt compute region. Still not the edge, by the way, but in all of my US customers go to west and east, maybe, but maybe just
Mm-hmm.
east. And provided, I've been thinking a lot about this, provided that your application itself does not have a strong dependency on doing cross workspace or cross customer joins, it might be a super awesome topology because it's still kind of like two or three or five regions, but you more naturally, by just installing the database, get the data to flow in all those locations. So sharding and Planet Scale talks about this a lot. Actually, Planet Scale has gotten this right from the outset. Like they've always said, like I think Zam had a tweet like, "You'll know that Amazon.com runs of one region, right? US East one, Amazon.com, and Planet Scale has very good replication offerings, very very good. And again, like you have to balance like cost and performance gains and whatnot.
Yeah. Okay, so it sounds like that can work, but it's not absolutely needed. I can't believe Amazon.com runs in just one
Yeah.
region. That's really blowing my mind right now. I have to assume Amazon.de probably serves from Frankfurt though.
One thing
Um,
to call out, by the way, is Vercel has a product called Edge Middleware. Fastly has a product called Compute at Edge. There's certain routing level rules, like sprinkles of JS that you can do for routing, which I still very much believe in. And believe it
this
or
is where, sorry.
yeah, so like think of it as like if the user has a cookie and I can rewrite between two paths or redirect, or maybe I can do some traffic steering. Like if the traffic comes from China, I have to rewrite the URL in a certain way and redirect it. Like I call that like sort of a traffic routing pattern. And that's why Lee and myself have been very careful to say that edge rendering is the problem, not necessarily like very tiny amounts of compute that mostly for the routing purpose. Because those are actually mostly stateless most of the time, by the way. So they don't have the data problem.
Yeah, I think this is what Stephen Tay, ex Vercelian's company dub.sh is built on, right? He built
Correct.
this using Edge middleware, this URL shortener, and
Yes.
now it's a whole company.
Yes.
Um,
And it's so fast.
yeah, yeah, it's fast because of that. Excellent. I think we've really uncovered a lot of things for the listeners here about performance and really identifying this blessed path, and also appreciating what Vercel saves a lot of people from. Because recently on X there was this long discussion by many people, including I don't know his name, unfortunately. Level Zio.
Level
About
CEO.
how it's you can go really far with just a single server somewhere in a data center that you manage. You could go far with a VPS. You don't need something like Vercel or Netlify or AWS. That was one side, and then the other side is actually no, this saves you from a lot of things, and gives you like dark fiber network access that you have to wire yourself otherwise. So can we maybe speak to that a little bit? And I don't this is obviously not
Yeah,
intended to be
it's
controversial or
funny.
anything. I
I think Level CEO and I have a lot more in common than it would seem from the outside because I do believe in that his simplifications are maybe overly simplistic for certain scales of products, but his simplifications are mostly correct, right? Like he uses PHP, server renders a bunch of stuff. When things get high traffic, he caches them. His only tool at the moment is he caches the entire page, to my knowledge. So like it gets complicated. And I think he operates mostly from VPSs, and he has some like DevOps expertise that, frankly, most people don't really have. Right, so that's
it's
something to
true.
call out. But again, provisioning and scaling VPSs and servers is the non-trivial job that you have to weigh. Because the awesome thing about serverless systems and frameworks that create infrastructure is precisely that you do not do that job yourself. So it ends up being
Yeah,
this equation of like, do I feel like I can invest my time and energy into the DevOps side of this? And do I have good, a very good model for how my system scales? Because I think what happens a lot with the VPS, and one of the things that always worried me a lot about the VPS system, and why I actually have never used it in my career except for like the first few years of my career, is this shared nature of the VPSs.
yeah,
You're basically getting a lower price at the expense of foregoing quality of service. Period. You're playing into an arbitrage of the hosting provider. Someone was saying on X yesterday, like, I cannot believe that Hertzner charges this, parenthesis, shared. As an
yeah,
engineer, I want to understand exactly what do you mean by shared? Shared
yeah,
with who? Shared with Bitcoin miners that are like blowing up the CPUs all of the time? Shared with mostly IO bound workloads? Awesome. But are they going to saturate the network because each network card has a certain amount of throughput?
yeah,
When we designed serverless functions and the decisions that we made in terms of how the product works, an extreme amount of consideration went into removing what I call the noisy neighbor problem. In fact, Vercel, and this is why when you like just do very simple math, you are paying more than traditional VPS compute. Vercel over indexes on quality. This is true for the
mhm,
priority of the dark fiber, where you don't share lower priority lanes with the rest of the internet. And it's true for compute, where you don't share CPU cycles with noisy neighbors. So you have to be extremely in tune with what you're getting from the as a performance characteristic from the system. In fact, some people say, "Well, my VPS doesn't have a cold boot." No, it has something worse. If you get these scheduled and you have a noisy neighbor, now like your server might not be responding for 2 seconds, 5 seconds, 10 seconds. Another thing that I encourage those people to think about is software upgrades. And if you have to update the like you get back to all of the problems that like cloud infrastructure was built to, and so you have to be very to solve it, you have to be very honest with yourself and others about whether you're saying like I don't care about these problems. So for example, upgrading your operating system will require a full reboot. And while the
yeah,
operating system is rebooting, you're not serving traffic. It might not even work by the time you come back. Like I know from experience,
yeah.
I spent my entire life being a Linux sysadmin since I was like 10 years old, and
Wow.
getting things to reliably start at boot up time is hard. With System
Yeah,
D and other systems, like things have gotten easier, but you have to worry about all the boot up time of all those systems so security is the other one that's huge. So making sure that your runtimes are patched, that your kernel is patched, that the operating system is patched, so on and so forth. Without getting too much into the weeds, the
Yeah.
most DDoS attacks that we receive on our network, and we mitigate hundreds of them per day, are actually increasingly coming from the clouds. They're coming from uh, a very popular hardware uh, colo provider that people are talking about. They come from AWS and Google Cloud themselves because people get pwned and then they
Yeah.
launch command and control center attacks from those clouds. So the security problem is actually non-trivial and something to be aware of when you choose to sort of DIY products like this.
Yeah. I think your advice rings really strong here, which is think like an economist, right? And if you think like if I think like an economist, based on all those things you mentioned, it sounds really expensive to have to either by money paying someone to care for these things or my own time. Like
Yeah,
if I'm spending my time like ensuring the right kernel is patched and so on, am I building my product?
right.
And for people like Levels.io, maybe he's got the proficiency where he doesn't need to invest so much time because of the strong DevOps background. But like
Yeah.
you said, this is maybe not everybody's
I also
everybody's
think,
cup
and
of
this
tea.
is
So
actually something that is worth imitating, like he does have a restraint. So because he's restrained to a certain set of tools, plus the
yeah,
expertise. So again, I love a lot of the alternatives that are out there, and I'm constantly learning and meeting people in the middle is usually how we've evolved this company. So as you know, we had a beginning with Zeit into like server side rendering or bust was my point of view. Then Jamstack and Gatsby started growing. And I think by the time you joined Vercel, you were entering this era of ISR where
it was
I
just before.
very consciously decided, no, 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 there's something interesting. Like all these people, we can't just be like, oh, they're wrong. Like let's
Yeah,
just keep doing our thing over here. In meeting people in the middle is where we've created the best things at Vercel. So we're constantly watching, learning, like trying to figure out, okay, like can I bring elements of that? Don't get your hopes up for like we're looking at launch of our self VPS product. That's not going to happen. But there's a lot of little things that we're constantly thinking about to understand people's and respond to people's feedback.
yeah. This is actually an interesting thing you bring up because when I joined Vercel, it was not. It was just before ISR, so it was when everything was serverless. Everything was serverless.
Yeah,
So it was, we're leaning heavy into Lambda. I remember we were talking about like deploying Python and C++
yes,
and running all of this stuff on
totally,
Lambda. And then, of course, we pivoted to ISR, probably because of this, right? Because of meeting people halfway.
totally.
Would you say and we're nearing the end of our discussion, so I'd love it if we could sort of wrap up talking about the journey of Vercel and glean insights for founders. This is the founder CEO series. We've got Matt Bielman from Netlify. We've got a bunch of others, and I think it's important to outline some of those experiences. There was a post. I forget where. I think it was by Evil Rabbit or some Vercelian about this is one of the inflection points of the web, and this was about Vercel. It was the moment where you ran now, the now
Yeah,
command, and it really made provisioning Node.js servers instant. And this was the moment. Full disclosure, I fell in love with Vercel. I was like, how can a command like this make my site live? Incredible, right? And that translates to today. I still, this is maybe not the blessed path, but I still deploy to Vercel by just running VC enter.
awesome.
And I know you want the GitHub flow and so on, but
Yeah,
we
I do
get
the
there
same.
once I'm
I'm
convinced the
also using the
project.
CLI.
Yeah. And so that I think was a huge inflection point. Can we speak to maybe some of them, particularly with an AI focus? I feel like we're at a similar inflection point now with AI. Where does that land in Vercel's story and journey?
Yeah, great points. So probably the biggest lesson that I shared is initially we totally nailed the DX. Like, I mean, you called it out. Even to today, like I met the other day with like one of my favorite companies in the world, and they're interested in using Vercel. And the very thing that the head of technology was excited about was that, oh, I get a deploy preview that easily, and my entire company can now collaborate with this. We don't have this. Oh my God.
Yeah.
So even that thing you're calling out is still so valuable to people. But the resulting output is what we spent a lot of time refining and focusing on. So when we were doing very general containers, it was like we were master of none, jack of all trades. I said that inverted, but totally masters of
Yeah.
none, jack of all trades. Um, and we started seeing success in the inflection point of the company when we started focusing. You called ISR as
Mhm.
an example of that, right? Because what happened is there were many solutions to host any general purpose container. Vercel had the DX leg up, but when the container was running, was it better, faster, more efficient? Did it have any interesting qualities? It took me a while to come to terms with the answer being no. Like it was actually pretty
Yeah.
generic. Whereas ISR, and we have an entire page of documentation on this, has like company saving benefits. And for folks on X, like like sometimes I like, but isn't that just like caching, whatever? I'll give you an example, right? So like if you're using ISR and it's Black Friday, ISR has this like cache shielding and dogpiling protection feature where if many requests come to a page that needs to be generated, we only send one request, more or less per region. I don't know the exact statistics, but maybe one or a handful to your backend. If you had shipped another system, a potentially a DIY system, all of the traffic comes to a drop that you've done, a sneaker, a website, a property, whatever, or your biggest launch that you've been preparing for so long. And now you've hammered your backend and now you're not serving your customers. So that's just a little example of a lot of the things we do. And that one is something that Vercel could do. It could orchestrate all these caches, those invalidation pipelines that we talked about, the 300 millisecond global purge. And yes, now there's a wide gap between the DIY, even, and it's not just about DX, it's about the operations side. It's about how much easier, how it puts me into the bit of success for me to succeed as a business later on in the life cycle of the application. And that's when we started, and that could only happen if we focused. Now we focused on frameworks, framework defined infrastructure. ISR is a feature that it has not just been used by Next.js, but also Nuxt and other frameworks. So that focus on what became the front-end cloud, and that's what we call Vercel, is what gave us a lot of success, which, again, kind of like the Levels IO example, it was about restraint. It's about doing less. And when you do less, you can optimize more.
That's such a great takeaway. If you do less, you can do more,
Yes.
or rather, it's more quality over quantity. And
Yes.
this
100%.
is not lost on me. This is also not lost on the listeners. I think every time Vercel comes up in a conversation, either in a podcast or in a conference, it's always, that's the thing that sticks with people, is there's always a tremendous amount of polish and quality for that. And I see that, I think there's also a lesson in here for people deploying applications and websites. It's more than just the first getting started
Yeah,
feature,
exactly.
as you said, right? It's
It's not the day one.
I
It's also
don't
the day, I call it like day 100 and day 1000. Yeah.
exactly. Now that your container is running, okay, now what? Is it fast? Is it? I love that
Yeah.
you ask the question, what comes next? And
Yeah.
I'm super thankful. Okay, in the spirit of wrapping up, you've been doing this for a long time, man. Like when we first met, it was 2017. It's now 7 years later. I have to assume Zeit began much before this. The company that you sold to Automatic probably even before
Yeah.
that. Um,
I'm old.
you've been a yeah, well, you've been a founder CEO for a long time, and you know what I've learned in talking to and having discussions with all of these folks here on the podcast. There is no standard, so to speak. There's everyone's different. Every founder CEO's role and responsibilities and things they do is different. But I'm trying to, in these discussions, like see what commonalities we have. Where are the common denominators? And like HTML is a living standard. It's a specification. I'm wondering if we can maybe take some of these commonalities and put them in like a charter for
That's awesome.
founder CEO.
The
So
founder spec.
with that, yeah, with that, what are some things that you feel should go in such a document?
I literally just tweeted about this one. I think building a product that you can use to build your product is something that's awesome. Like something that like really speaks to you as a founder. I use my product all the time. Like I need to see this in the world. And that's one of the things that'll push you through the ups and downs of building a startup is that even if like I'm not feeling 100% today, like the idea of this product being necessary because I love it and I love the idea and people need it overrides anything. It's
Mm.
it's a purpose that's greater than the life of the founder even, hopefully. So there's that element. I think there's a lot around, for me in particular, it's about quality. I'm very grateful to, and people can talk shit about VCs. I do it too, by the way, in part of the club. I'm very thankful that there's such a system that exists, and not just in the US, but increasingly globally, to bet on young entrepreneurs that want to do extremely ambitious things. And they it takes a whole lot of time, but it takes a whole lot of resources. But it's amazing that you can have this bold ideas, visions, etc., and you can get the resources, and you have to act accordingly. So that I use this also as a barometer for myself. You spoke about quality. This is a little known fact to most people, but like, so VCs, we raise money from VCs. VCs have to raise money from other people. It's not just like their own personal capital. So they raise money from institutions like the Children's Cancer Hospital Endowment in Boston, like as an example. That
Wow.
capital flows into the venture capital, flows into the startup entrepreneurs. So that's just maybe an extreme example to like root yourself into, like, if I'm not striving to create the absolute most helpful, highest quality product on the planet, I'm literally squandering the time resources of like some of the most important institutions in the planet. So I think going back to quality, like you really, really, really want to work on something that you're really proud of and other people will be proud of, because it's almost like a collective effort. And obviously your colleagues, your board, your people that you hire want to be proud of that and feel motivated to do it. So that's another thing I think a lot about is, especially if you take this like venture capital route, there's so many ways of building businesses and there's so many ways of delivering value to people, even nonprofits, right? So, but I think it's important to like understand and build things that are commensurate to each system.
Yeah. Awesome. Can I share with you one thing that I really took away from my time at Vercel? It was very short, but what I took away that still sticks with me to this day, is y'all have had, I don't know if this is still the case, it looks like it. Y'all had an enormous amount of attention to detail with everything. Like I still remember working on the documentation with Timothy. I don't know if he's still at Vercel, but we were working on the docs for serverless, and everything had to go through a number of review stages, which I appreciated. I know this sounds like judgment, like, oh, it's taking too long. I actually appreciated that, but also everything had to go through Evil Rabbit. For does this have an OG image?
Yeah.
And then there was I don't know if I'm leaking
No, no,
details
no,
here, but
it's awesome.
there was a Twitter staging account where we post tweets to this private staging account and make sure the OG image looks good and the links are appropriately, the card looks right and everything. And then finally, we ship, making sure that we've done our absolute best to ensure quality. Is it still like that? And
Yes.
two, how in the world do you balance that with rapid shipping? Like I've worked with so many founders over the years since then, who, hey, we need to ship. I get that it's ugly, but like, what is it? Done is better than perfect. Let's throw something at the wall and see if it sticks, and let's find product market fit, and then we'll get there. This doesn't seem to have been the case for Vercel. So, can we speak to maybe balancing those two sides?
Yeah. So on the first is absolutely the case. If anything, it's gotten even more intense. It's getting, but with the
Nice.
use of technology, it's gotten easier. So like instead of staging in random accounts, we use a product called Typefully that the founders are awesome. Spent a lot of time making sure that their representation of the draft of the tweet is exactly the same one that you're going to see on
Wow.
Twitter. So we have a lot of great tools to streamline a lot of those reviews and processes. We use our own product a lot, like Vercel Toolbar with our comment feature to like leave comments all over the documentation. So that kind of goes back to like use your product to build your product. So a lot of the things that you called out are like that yields to a high quality outcome. Imagine if now you put those into the platform, and then now imagine that other companies can use them to build awesome things and ship them fast. In fact, Stephen Tay is a good example of like, because he learned a lot of these mechanisms and they're now put into the platform. I feel like he's moving so fast, but also with high quality.
Yeah.
Like, so I think there's maybe that answers the second part of your question. I don't believe that moving fast should come at the expense of quality, but I also do believe that you have to sometimes take a step back and put more wood behind fewer arrows, and maybe
Mm.
say, okay, I'm going to put a lot of effort behind this one launch. In the meantime, I'm going to ship a lot of experiments, feature flags. So you should never slow down your shipping because there's a launch coming or whatever. But I do think, again, like make it worthwhile, right? Like make it work well. Make sure that, people click and the product works. Like this sounds silly. I'm going to leak another like Vercel internal like meme, which is like, I don't know if you remember this, but like DHH had gotten kicked out of the App Store, like Hey was not published. And one of the Apple
Yeah.
execs defended that, saying, we hate it when you download an app from the App Store and it doesn't work. And to me, this
Yeah.
like that little comment is why Apple is such a successful and special company. Because yes, you could argue that these people are evil and their App Store and whatever, and there's truth to the fact that it's like a walled garden, and I don't like that aspect of it. But the fact that he's thinking about that end user who finds Hey and wants to like very quickly use it and doesn't get value from it really resonated with me, because I've seen this failure mode in myself where you get really amped about shipping and announcing something, and people go click, click, doesn't work. Or even
Yeah.
worse, click, 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 sign up, click, 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 click. And then maybe like they just even lost attention and time and energy at that
Yeah.
point. So
Or they made like 5 accounts and they need to somehow. Yeah.
and they can't even find where the feature that you announced was in a maze of
Yeah.
GUI. And so you have to like think about that intentionality of the funnel. And it starts with like, how are people finding out about this? Increasingly, it's on
Yeah.
X or some email campaign, and then like think about that funnel and like think about the call to action and be intentional.
Mm. Incredible. Well, Guillermo, listen, it's been such a pleasure. Thank you for making the time to come chat with us, me, the listeners on the podcast. On behalf of myself and everyone, we're so thankful and impressed by the quality that Vercel ships, the pace at which Vercel ships, and all of it with your leadership and the leadership team. Excuse me. So, on behalf of me and all the listeners, thank you
Thank you
so
so
much for
much. That
coming on
was
the
super fun.
podcast and sharing all of this with us. Thank you for joining my discussion with Guillermo Rauch. Wasn't it worth it? Wasn't it full of great? I certainly enjoyed it, and I hope that you did as well. If you did, if you learned something, if you just generally enjoyed it, I'd invite you to leave up to a 5-star review on Apple and or Spotify. If you're listening to this or watching it on YouTube, please subscribe to the channel, leave a thumbs up, and maybe a comment. All of this really helps the channel, and more than that, it's a signal to me of whether this stuff is actually valuable and if I should keep doing it or not. So your feedback really, really helps in so many ways, and I'd encourage you to do that. Thank you also to the sponsors. If you want to sponsor the podcast, you know where to find me. I'd love to bring people to your thing, or if you're altruistic and you want to, anyway, whatever. We'll talk about that. Thank you for sticking around. Thank you for joining this episode. Thank you, most importantly, for your interest in engineering.